Welcome back, everybody. Here are some more examples of finding the domain of a function, including radicals. Looking at our first example, since we can't have a zero in the bottom of the fraction, instead of writing greater than or equal to 0, we'll just have to write greater than and solve. So let's begin. We have x plus 2 is greater than 0, and then subtracting negative 2 from both sides, we're going to get x is greater than negative 2. And in interval notation, this is going to give us negative 2 to infinity. Now looking at this problem, unlike the previous example where the square root is in the denominator, we can set the numerator greater than or equal to 0. So x minus 2 is greater than or equal to 0. And then if we add 2 on both sides, we're going to get x is greater than or equal to 2. And since we can't have a 0 in the denominator, what we can do with x squared minus 16 is that we can factor it, and then we can get x plus 4 times x minus 4. That's going to give us two values, which is x is equal to negative 4 and x is 4. Now making a number line, we have 2, and we have negative 4 and 4. So we can start by writing negative 4 here, 2, and 4. So basically, we have x is greater than or equal to 2. So it's all numbers greater than 2, but not including 4 and negative 4. So this is unshaded here and unshaded here. We're going to put a shaded circle here. And that's going to go to infinity. But since this region is included, we have to include it in our interval notation. So the domain of this function is going to be 2, don't forget to put the closed bracket since 2 is included, 2 to 4, open bracket since 4 is not included, union, I'm just going to put the u at the bottom here just to make some space for the other example, and then 4 to infinity. Now this is a slightly more difficult problem since we have radicals in the numerator and the denominator. What we can begin with is by taking the numerator, and since it's not in the denominator, we can set it greater than or equal to 0. And then subtracting 2 from both sides, we're going to get x is greater than negative 2, greater than or equal to negative 2. Now looking at the bottom, since we can't have zeros in the denominator, we're going to get x is greater than, x squared, minus 16 is greater than 0. And then if we factor it, we're going to get x plus 4 times x minus 4. And that's all greater than 0. So since we have negative 2, negative 4, and 4, we have to begin by constructing a number line. First of all, for negative 2, we can see that 2 is included and is going to go to infinity. However, for negative 4 and 4, here it's important to use a line test, choose values, plug them into the equation just to see where the domain is real. Now if I choose negative 5, plug it in here, negative 5 plus 4 is going to give me a negative. And then negative 5 minus 4 is also going to give me a negative. And then negative times negative is going to give me positive. Now if I choose a value between negative 4 and 4, let's say 0, 0 plus 4 is going to give me 4, which is positive. 0 minus 4 is going to give me negative. And then negative times positive is negative. Then choosing a value greater than 4, let's say 5. 5 plus 4 is 9, which is positive. And then 5 minus 4 is 1, which is still positive. So it's going to be positive here. Now here's the thing. We have to plot all our numbers on a single number line to produce one single interval notation. So I'm going to need some space here. Let me try to tilt the camera. So I'll look for a different color. Okay. Notice how this is positive here, and then this is negative. We have to find a relationship between both lines where the numbers apply, where the numbers are real and overlap. So for instance, negative 2 is somewhere here. Since we don't need this part, we can exclude all this. That means negative 4 is unneeded. Now the region between negative 2 and 4, we don't really have anything since it doesn't work for the first number line. So the answer must be somewhere between, but the answer must be 4 to infinity. Notice how this idea is true for the first and second number line. Because there's a 4 somewhere here. And since there's a 4 here and it lies in the positive region, 4 has to be included. However, since negative 2 is not included, we can't include that in our interval notation. So as I said before, between negative 2 and 4, we don't have anything since it works for the first number line and not the second number line. So it must be from 4 to infinity. If you encounter a problem where you have a square root in the numerator and the denominator, it's easy to construct two number lines and find a section where both number lines overlap. So since this region is unneeded, the domain is simply going to be from 4 to infinity. So the answer is going to be from 4 to infinity. However, 4 is not included. We must not forget to write that. Otherwise, our answer is going to be wrong. So it's going to be 4 to infinity. This is a fairly difficult problem. I've had trouble before when I first encountered something like this, because When you're trying to find the domain of a radical function, it can get a little tricky, but the more you practice, the more you'll get the hang of it. So keep practicing some more problems. Please don't forget to like this video and subscribe. That'll help grow the channel more and more. And we'll see you in the next video.